Hello everyone, today we will explain about X-ray radiography and dosimetry experiment, which is experiment N1. Our group members are Limle and Ayu Asmida binti Ayub. For part 1, which is radiographic examination of objects, there are two objectives. First, to observe how different objects appear when exposed to X-ray on fluorescent screen. Second, to study the effect of changing anode current and anode voltage of the X-ray tube on the fluorescent screen. These are the equipment and materials needed for part 1 of this experiment. First, the optical bench was installed and the fluorescent screen was mounted securely and positioned at the far right of the bench. Next, the object was placed about 30 cm in front of the fluorescent screen using an object stage to ensure a proper alignment. After that, the door was closed and locked and the X-radiation was activated. The anode voltage and current were then adjusted through the menu and the required X-ray parameter was selected and confirmed. Finally, images were taken at different currents while keeping the voltage constant and at different voltage while keeping the current constant. For objective in part 2, X-ray dosimetry was performed to determine ion current using two diaphragm tubes with different aperture sizes. Secondly, to calculate the ion dose rate, energy dose rate and local ion dose rate based on the ion saturation current. Then, to measure the ion currents at different anode currents while keeping the anode and capacitor voltage at their maximum values. Finally, to determine the ion currents and different anode voltage with the maximum anode current and capacitor voltage. These are the materials and equipments for part 2. For part 2 X-ray dosimetry experiment, first, the experiment was set as shown in this video. The anode voltage was set to 35 kV with fixed anode current of 1 mA. For table 1, the ionization current was measured from 30 V to 600 V. The apertures of 2 mm was changed to 5 mm. The same steps were repeated to get ionization current value for 5 mm. For table 2, with diagram tube 5 mm, the anode voltage and capacitor voltage was set to 35 kV and 500 V respectively. Ionization current was measured from 0.1 to 1 mA in table 2. Last but not least, with diagram tube 5 mm also, the anode current and capacitor voltage was set to 1 mA and 500 V respectively. Ionization current was measured from 10 to 35 in step of 5 kV in table 3. Next, this is the result that we obtained for part 1, which is for constant anode voltage for different anode current, and for table 2, it for constant anode current but different anode voltage. Next, we move to the task 1 for part 1. For task 1, the object was exposed to X-ray and the resulting image was observed on the fluorescent screen. When the X-ray passed through the object, an image appeared on the screen. Differences in brightness were observed across the image, where some parts appear brighter while other parts appear darker. For task 2, as the anode current increased, the image became brighter. When the anode voltage increased, the X-ray became more penetrating, which affected the visibility of the image. However, the image didn't always become clearer, as higher voltage can reduce visible contrast or overexpose the fluorescent screen, that causing some image details to be lost. For task 3, in the presence of X-rays, the image observed on the fluorescent screen showed varying brightness due to the differences in X-ray absorption and transmission by different regions of the object. The brightness of the image increased with an increase in the number of X-ray photons, which occur when the anode current was increased. Increasing the anode voltage raised the energy and penetrating power of the X-ray beam, thereby altering the visibility of internal features. However, at higher voltage, the image contrast sometimes decreased due to the excessive penetration, increased scatter, and overexposure of the fluorescent screen.
So now moving on to part 2 of this experiment, which is about X-ray dosimetry. Table 1, 2 and 3 were listed as shown in the slides. The graphs of this experiment were all plotted using Excel. For task 1, the graphs of ionization current against capacitor voltage for both apertures were plotted first. After that, we moved on to task 2, which is the calculations. The measured X0, X1 and X2 were 2 cm, 10.7 cm and 20.1 cm respectively. By using the equations provided, the ion dose rate, energy dose rate for both apertures, and the local ion dose rate at capacitor start, middle and end of aperture D equals 5 mm were calculated. The calculated values were then summarized in tables. For task 3, the graph of ionization current against anode current was plotted. Based on the graph, it illustrates a straight line exhibiting a positive slope. The obtained linear equation is y equals to 0.0744x plus 0.118. Therefore, it can be concluded that the ionization current is directly proportional to the anode current with a linear relationship between them. For task 4, the graph of ionization current against anode voltage was plotted. Based on the graph, it shows an increasing curve rather than a straight line. Hence, it is concluded that the ionization current increases non-linearly with anode voltage. As for the discussion, I will just briefly summarize the main points for the sake of the video. Firstly, we stated the objectives of this experiment. Next, we explained the reason that the fluorescent lamp starter and the shell were chosen for part 1 of the experiment and discussed its results. As for part 2 of the experiment, we first discussed the graphs of ionization current against capacitor voltage for both apertures and its related calculations. Then, we discussed the relationships by using the graphs of ionization current against anode current and anode voltage. Finally, we mentioned the source of errors, the methods to alleviate them, and the precaution done in this experiment. In conclusion, in part 1, increasing anode voltage increased the image brightness on the fluorescent screen, while increasing anode voltage changed penetration and visibility, and at high voltage the visible contrast could decrease. The calculated values were shown here. The ionization current showed a linear relationship with anode current, but showed a non-linear relationship with both capacitor voltage and anode voltage. Here is the list of references, and here is the verified data. That is all from us. Thank you.